Hi everyone, I'm Ramesh, Assistant Professor, Department of Mathematics, Dr. SNS Rajalakshmi College of Arts and Science. Welcome all of you for this case study. So today case studies we are going to analyze the chi-square test, independence of attributes. So first, what is chi-square test? Chi-square test is based on non-parametric test, and the test is introduced by Carl Pearsons in the year 1900. The test is the main theme of this test is there is any difference between expected value and the observed value. Using the formula, chi-square is equal to summation of observed minus expected the whole square by expected. So here, this O means observed frequency or observed data, and E is expected data. Okay. So next, so the conditions when you apply this chi-square test, if the n is the number of data, the total frequency should reasonably large, say that it is greater than 50. The number of data is greater than 50, then we apply this chi-square test, and the sample observation should be independently. No theoretical frequency is less than 5, so definitely it should be greater than 5. And the constraints of the cell frequency must be linear, that is the sum of observed value and the sum of expected value. If both are equal, then it is linear, then we apply the chi-square test. Next, the step first we form the null hypothesis. Is there any significant difference? What is null hypothesis? There is no significant difference between observed data and the expected data. And similarly for the alternative hypothesis, there is a difference in observed and expected data using the same formula. So next we find the level of significance. Then we check whether the level of significance value is less than or greater than the table value, and we apply the calculated value. If the table value is less than calculated value, then we reject. If the calculated value is less than the table value, then we accept the H0. So using all these informations, we got the problem. So chi-square test independence of attributes, what is that? We form the cell formations. So the data are allocated, and we apply two data, and we analyze is there any independence or any relations of the two data. So that purpose we apply this chi-square test. The next is the problem statement. So next we form the contingency table. Suppose there are A, B and C, D. There are 4 values, and sum of the two values A plus B, and in the column wise it is A plus C, and row wise it is C plus D, and the column wise B plus D. So total sum on that row and the columns are capital N. So total value is A plus B plus C plus D. So it is our observed data, observed frequency, and the expected frequency is calculated by, suppose what is the expected frequency of this A, its corresponding row value is A plus B, corresponding column value is A plus C. So A plus B into A plus C divided by capital N. So that is the expected value of that A. Likewise B, C and D. So this one is called the contingency table. Yes. Now we got the problem statement. So we analyze this case study using on chi-square test. What is the problem statement? Anybody?
In the problem statement, a survey among women was conducted to study the family life. The observation divided into 2 types, happy and non-happy, based on education and non-education. Education 70% happy, non-educated happy 60%, not happy educated 30%, and non-educated non-happy 40%. Hence, the observation test whether there is any relation between family life and education.
Yes. Yes, by the statements here, the survey amongst women, so there are 2 types of surveys. One is for the study of family is depend on happy or not happy based on the educated or non-educated. Say here, educated 70 are happy and not happy 30 from the educated side. And the not educated side 60 are happy and 40 are not happy. Using this survey, we test whether is there any relations between the family for education and the happiness. So, okay, we discuss this. So next, how we proceed this? Yes. So first we form the null hypothesis. Okay, from the statements we have some conclusions, and first we form the null hypothesis. What is null hypothesis?
So null hypothesis, there is no association between family life and education life, sir.
Very good. So null hypothesis is family life and education life. Good, right. So here, So next we form the contingency table. So it has 2 rows and 2 columns. Therefore, we form the 2 by 2 contingency table using this educated and not educated. It depends on the happy and unhappy, 70, 30, 60 and 40. So these all are observed data. So 70, educated side, 70% people are happy. So what is our expectations? How we calculated the expected data? Anybody? Yes.
So expected value of 70 is for the row column it's 100, and for the column of happy is 130. So 130 into 100, and for the whole total is 200. So divided by 200 will be 65. And for the expected value of 30, the row value is 100 and the column value is 70. So divided by the total number of terms 200, it will be 35.
Okay, good. The expected value of 60. So it is 60. So how calculate the expected value of 60? Corresponding total is 100 into corresponding column total is 130 by grand total 200. Then we get 65. Likewise, the expected value of 40. So 100 into 70 multiple of these two divided by 200, it becomes 35. So these are all the expected value. So from this, we form the table observed. We write all the observed values 70, 30, 60, 40, and the expected value already all are explained, this 65, 35, 65, 30. Then the difference of these two, difference between observed and expected, 70 minus 65, 5, 30 minus 35 minus 5, and minus 5, 5. Then it is square value is 25, 25, 25, each are 25. Then as per formula, we need what is observed minus expected, the whole square we expected. That is, divide this 25 by that 65, then we get 0.385. Likewise, 25 divided by the C value is 35 is a 0.714 and so on. So finally, we find sum of all the values. It is a 2.198. Okay. So it is our table. From the table, we calculated what is the summation of observed minus expected the whole square by expected value. So our calculated value here is 2.198. Okay. Right. Next, we find the degrees of freedom. Yes. What is the degrees of freedom of this contingency table? 2 by 2 contingency table. What is the degrees of
Row
freedom?
1, column 1, sir. 2 minus 1, 2 minus 1 is equal to 1 d.5, sir.
Okay, right. So here the degrees of freedom is this is a 2 by 2 contingency table. It has 2 rows and 2 columns. Therefore, the degrees of freedom is row minus 1 into column minus 1. So 2 minus 1, 2 minus 1, that is equal to 1 degrees of freedom. Good. Good. So it is a 5% degrees of freedom value. 1 degrees of freedom value is 3.84. Actually, already our table value is 2.19 something. This critical value is 3.84. So from these two, how we connect? Yes, yes. How you connect this?
Since the table value is less than 3.84, so we accept the hypothesis.
Yeah, because the table value, that is already we calculated the value become 2 point something, but the table value or critical value is 3 point something. So calculated value is less than this table value.
So we accept the hypothesis.
Yeah, we can see this. Very good. So this table value is this already the table value we calculated. That one is less than the table value. The calculated value is less than this table value. Therefore, we accept the hypothesis. Okay. So final stage of this case analysis. What's the conclusion of this? Yes.
Sir, from all the above discussion, we can conclude that there is no association between the family life and education.
Because we accept.
Yes, sir.
We accept the null hypothesis. What is the null hypothesis? Already he told that there is no difference between family relations of these two.
Absolutely.
Family life and this one. So therefore, as per this conclusion, there is no association between family life and education. Good. That's all. Thank you. Thanks to all.